So the next topic we'll start with is overriding versus overloading. So Ben, do you remember what overloading means? Overloading means when two methods have the same name but different signature. The types and the order of the parameters will vary. Then there is a concept of overriding. In overriding, what it means is in the derived class, you override a certain method which is defined in the base class. So as the word override means to to change something, to alter something. So you are altering the behavior which is in the parent class, in the derived class. So in the parent class you have a certain method, and in the derived class you override it. You override it means you change it or modify it. To override a method, the method in the subclass, it needs to have the same signature. See this part? Should have the same signature. If the subclass defines a method with the same name as one in the base class but a different signature, the method is actually overloaded but not overridden. Okay, so let's try a simple example where we will show what overloading and what overriding means. 6.28. Let's see whether I have an example of this. Did we do this overloading a method? For example, here I have a class called test overloading. Okay, so if you see here, I have a print method. It is the same name but different signature. One I have a string, and another one I have two strings. Third one I have a string and an integer. So this is method overloading, right? Because the arguments are different, the types are different, the names are still the same. So here I'm creating an object of test overloading, and then on line 19, Ben, can you tell me which method it is going to call? The first one. Good. Okay, line 20, which one is it going to call? Yes. And 21? Good. So now you understand what overloading means, right? So based on the types you recognized which method it is going to call. So the way you recognize it, the JVM is also going to recognize it at by looking at it. It's able to determine by what you have typed here. So that is called as static polymorphism. So overloading is a form of static polymorphism. So next, what I think you already have this, I think, right? Do you know? We already did this, right? Oh, I just mentioned it. So we didn't do this, right? Okay. Something we have done something similar. Okay. So let me send you this, and let's also look at overriding. Okay. So this class, I just want to rename it as demo overloading because all my classes are starts with the demo word. Then let's look at an example of overriding. Okay. I think I don't have that example, so let's create one. No, don't do anything. I'll. I told you yesterday also, right? We look at the example that this guy uses. There's a class called employee and the class called manager. So the manager class has what is called, he has some responsibilities. An employee just does what the manager tells him to do. Okay, but the manager will be responsible for many things. Okay, one of the things will store what he is responsible for in this. Okay, whereas an employee just has a name and an SSN. Okay, so let's take this. And create a new class called manager, and his superclass would be employee. Employee would be the base class or the superclass, and manager is the subclass or the derived class. Super always means parent. Yes. But both are basically employees. Yeah. So I'm creating the constructor for the base class, which is employee class, right? And then I'll add a few methods for the getters and setters. And there you can choose which fields you want to have the getters and setters. So it will generate the getters and setters with public access. And the manager guy, and then we need to have a print method in the employee class. Yeah, once again, name assistant. So I'm creating a demo override class in which I'll have this. So I'm creating a manager called Bob, this social security number, and his responsibility is development, or say manage cleaning department. Oh, employee has some vacation days. So let's create a vacation days as an attribute of an employee. So the manager guy, employee has, the manager has more vacation days. Okay. So no, so in the employee class, we'll have something called as base vacation days, extra vacation days. And then generate some getters and setters for both of those. Okay, save that guy, and the demo override. Because we need the getters and setters because the attributes are private. so you cannot access it outside the class. Provide the getters and setters and make them public. Right. And in the employee we have a print. In the manager we have a print. So the manager's print, we need a header and a footer. And in the footer we'll say and employee.java. The print will also print the vacation days and the extra vacation days. So what's happening is this print method in the manager is overriding the print method of the employee. Overriding means it's altering the behavior. So here we first print the base class print, and the base class is the employee class. And the print of the employee class, we just print the header first, and then we'll print, let's add it will print all this, and it comes to the manager, and then it prints the responsibility, and then it prints the footer. So let's run this, okay? So you say run as Java application. So if you see this, so it prints the manager details, name, SSN, base vacation days, extra vacation days, and then it will print the responsibility. So this part is being printed in the employee class, and this part is being printed in the manager class. Okay? Yes. Sorry? So we have one class called employee. They are in the same package, yes. So whatever is common to the should be there in the employee class. I'm putting it in the employee class. But employees doesn't have responsibilities. Only a manager has a responsibility. And column and then I go to the manager class, and yes. So in this class, in the manager print, I print the employees print first. So here first call the parent class print. The parent class here is Yes. So here instead of parent class, first call the base class is print. The base class is nothing but parent class. You get it? So this print method, if you see, it's an override. There's a print method in the base class also. So for an overridden method, so I'm going to add some Java docs for this. And how do we add Java docs? Alt, Shift and J. Actually what you can do here is, you can provide a Java annotation called override. So someone who is reading your program, he knows that you're overriding the parent class's print method. Okay, let's try to remove this footer from here. Okay, and see what happens. The method print of type manager must override a superclass method. Now there is no method called print which takes a single argument string in the parent class. That's why it's complaining about it. Because if you go into the employee class, the print takes a header and a footer. Sorry? So what you can do is, you can overload it if you want. So for example, this guy is not using the footer, right? Is he using the footer anyways? So if I remove it, and in here I'll go and remove the override and add the footer here, because this guy needs a footer, and then remove this null from here because it takes only a single argument. Now this guy, it's an overload. Overload means same method name but different parameter types and order. Here it is taking 2 parameters, whereas in the base class it is taking a single parameter. Okay, so since this is an example of override, I'm going to leave this as it is. So let me send you these 3 programs. This is overriding the parent. Because the signature is the same. When the signature is the same and you put this override annotation is like a tag. So you are informing the JVM that this print is overriding the parent class override print method. And to override, you always need to have the same signature. Okay, when someone looks at your class, he looks at all your methods. Okay, and you are putting the responsibility of printing in the method called print. So you want the print interface to look the same whether it is in the base class or in the derived class. Like for example, an animal walks, right? Different kinds of animal walk, but they may walk differently. So all the walk methods of the animal class and the derived classes of the animal should have the same signature. But certain animals can walk in a different way. Some will use their 4 limbs, some will use only 2 limbs. Right? So the behavior is different in the derived classes. Can be different. It may not be different for every derived class. Some derived classes can override the parent class's behavior, and some may just use the behavior of the parent class. Right. Yeah. Yes. Right. So here, for example, so this is an example of overriding. Super is to invoke anything from the parent class, from the base class, yes. And when you just use super without the dot, it means you're using the parent class's constructor. Remember when we invoke the base class constructor, we just said super and we pass some arguments to it, right? So the big difference between override and overload is, for override, the method signature has to be the same. And for overload, the method name is the same, but the parameter names and types are different. Same name, but still having different signatures. The parameter types and order, not the parameter names. See here, the signature of a method consists of the method name and the parameter list, that is the parameter types and their order. So if the method name is the same, and still if two methods have different are overloaded, then the only thing that can vary is the parameter list, which is the parameter types and their order. So two methods with the same name and different signature are said to be overloaded. But two methods with the same signature, it cannot appear in the same class. For example, it can be overridden only in the derived class. So for example, I cannot add another print method here in the same class. It will think that it's a duplicate definition. But I can add a method with a different signature in the same class, and then it will be an overload. See, in this method, I'm not printing the footer. Okay, now I'm going to provide this method also as an override. Okay, so I'm going to remove this footer here, and then I need to create that print method in the base class also. And in that, I'm going to call One second. And here I'll add a override. So now it is overriding the parent. So this one doesn't print the footer. Okay, this one. So in the demo override, I'll create one more print where I don't pass the second argument. So it will go into the manager's print method, which takes a single argument, which is this, and print the parent class's header by doing the super.print, and then it will print the responsibility. So let's run this. Okay. So this was, the first one was the manager details. So it prints the footer. Okay, the footer I'll just put an end, okay, so that you'll know that it's the end. And then here I'll put a sys. So this was, in the first one it prints the footer. This is a footer. The second one, it does not print the footer, but it is printing the responsibility twice. Why is that? It prints the super.print, and then it is printing the responsibility, and super.print is calling the print. Oh, and this print is a derived class print, so don't do that. So let's do one thing. Okay, I'm not okay, I'll just comment this line out. See, this is called as refactoring. So I'm creating a method called print header, and see what happens. And then I'll refactor this into another method. Right click on it, say refactor, extract method. Okay, and for this I'm going to say print attributes. Right, that's what it's doing, right? So it'll print the header and print the attributes. And in this guy, where I have single one, I'll say print header. I am not duplicating the code. I don't want to duplicate the code. Print header takes a header, and then print attributes. Now let's run this again. See, now it printed only once. Run. I'll send you this, and I want you to tell me the answer of why it was behaving differently when let me send you this. Then you can answer that question. Okay. So I'm going to zip up this override folder and send it to you. Okay. Sorry. Extract the zip file in com.training folder. Okay. I'm going to send you a zip file. You extract in the com.training folder and refresh Eclipse. No need to create any class. If you have created a class, delete it please. Okay, I sent it. Yeah. In the email which I sent, I told you where to extract it. Extract it under workspace, training, source, com, training. Sorry? What the, yeah? A null character. There's, it's not a null character, it's a null keyword. Null means some unknown value. Or unknown or undefined. Actually, it means undefined. Oh, here that means you're passing the null for the super print method. There's a print method which takes a header and a footer in the parent class. For the footer, you're passing null. That means that string is not defined. Footer will not be defined. It's empty. You can think of it as, it's not empty. Empty means nothing between the double quotes, right? Like this would be empty, right? For example, instead of this is an empty string. But empty string is still it's defined to be an empty string. But instead of empty, I'm just saying it's null. When you have null, there is no memory allocated for it. But if it is an empty string, there is still some memory allocated for it. So did you all run this program? Okay. Did you see what I did over here in the employee class? When I printed, first I had everything in like this, whatever we have in the print header and the print attributes, I had all of them in one method. Okay. So by extracting it into a method, I can reuse it in multiple places. See, I reuse that print header over here and also over here. Whereas if I didn't have a method to extract, if I didn't use a method, that same code I would have had to duplicate. So that print header code, where is the print header code? Here. So these 4 lines, 1, 2, 3, 4 lines, I would have to write here and also over here. So that's the advantage of having a small method, because you can reuse it in multiple places. Similarly, the print attributes, I'm using it over here and also over here. And print attributes is how many lines of code? 4 lines of code. So instead of having 8 lines of code, now I have only 2 lines of code, right? One here and one here. I define it over here. Okay. So I'll ask you a set of questions now, Ben. So in the manager class, this print method and this print method here, do you call them as overloaded methods or overridden methods? So what's your answer? Overloaded or overridden? These two methods. So these two are overloaded, right? Because they have different signatures. But this guy and this guy are overloaded methods, right? They have different signatures. But each of them independently is overriding the parent. This guy is overriding the parent sprint that takes header and footer, and this guy is also overriding the parent sprint which takes only a header. Yes. Override means, okay, you see the sprint, right? How many arguments does it take? 2, and they are both strings. So when I said overriding means is always in the context of a parent class and a derived class. So you override what's in the parent class. So there has to be a method called print which takes a header and a footer in the parent class also, and you're overriding that. Overriding means you're changing what's in the parent. Right. Which one? The super.print is a parent. Let's do one thing, okay? Go and comment this out, this part of the code, okay? And your program will still run. Because then what it's going to do is it's going to invoke the parent sprint. And the parent sprint will only invoke the header and the attributes. So let's run this, okay? I'm going to run this. So if you go and see there, he's a manager, right? But it did not print the manager's responsibility. And it also did not print the footer. And why it worked? Because this print is going to the employee sprint now. It is not going to the manager sprint. And the parent sprint, so if I just click on this, do one thing, press the control key and press print. It will take you to the employee sprint. Okay, do this now, okay? Go to the manager class and comment out the print which takes 2 arguments. Can you do that? Okay, before you do that, go to the demo override, go to line number 12 and press control. When you press the control, you see that hand sign which comes, and then click it. No, don't comment it out. Go to line number 12 in the demo override. Can you not see over there, Ben? Sometimes. Not double click. Control and press the left click. Click it. Control and left click. Where is it taking you? Okay, you have it. Go to the Eclipse hotkey and search for Okay, if it doesn't work for you, if the control and the left arrow doesn't work, go to the print method and press F3. You have to be on the print method. The cursor should be on the print method. Can you go to the line number 12, put the cursor on line number 12 and press the F3 key. F3. F3 or control click. So where did it take you? To the print method of the manager, right? That means it resolved it to the print method of the manager. Now comment out that method print in the manager, starting before the override. So go to the manager class and comment it out like this. Did you all do that, Silva? And when you comment it out and you try to go through it, it will take you to the employee sprint. You understand that now? Okay, did you comment it out, Ben? Can you help out Anne Silva? No. What did you do so far? Okay, now go back to demo override. Okay. And control left click or F3. You can do either of the two. Put your cursor on the print method and press control left click or the F3 key. Either of the two will work. Then, did you do that, Ben? Employee sprint, because you commented out the derived classes sprint. Because it's a override method, right? It's the same signature. If it doesn't find in the current class, it will go and look in the parent class. Because the current class you commented it out, right? Okay. Now go to line number 14. Go to line number 14 in the demo override and press the F3 key. And where did it take you? Dominion. Go to demo override. Put your cursor on the print method and press F3. Before you press F3, can you guess where it will take you? Manager classes print method, which takes a single argument. Do that. Verify it did take you. Okay, now go and comment out this method also. In managers print, which takes a single argument. And go back to the demo override and press the F3 key now. Where do you think it will take you? Take you to the parent employee, the print of the employee class, because you have commented out the derived classes print method also. Inyang, how is it going? Horrible. Okay, which part are you not following? Sorry? What happened? So I'm going to stop this guy recording. Okay, let's get started. Can I get your attention, please? So the next topic we are going to talk about is abstract classes and interfaces. An abstract class is a class which has at least one abstract method. An abstract method just has a method signature. So it has only a declaration. It doesn't have any body. Whereas a concrete method has a body. The body of a method basically means the method has a definition. Whereas an abstract method only has a declaration. It only has a signature, no body. The body of a method is inside curly braces. One or more statements inside curly braces. So an abstract class can have a few concrete methods. All it needs is one abstract method to make the whole class abstract. But it needs to have at least one abstract method. Okay? Yes. In Java, there's a concept of an interface. So there's a keyword called interface, like you have the keyword class. Okay? So you declare an interface by saying public interface and the interface name. the same way that you declare a class. You declare a class by saying public class and the class name, right? So similarly for an interface, you say public interface and the interface name. In an interface, all the methods are abstract. You cannot have even a single method which is concrete. What is the point? Good question. Yes, good question. So the second thing answers your question. In Java, you cannot have multiple inheritance. So every class can extend only one other class. Can inherit from only one class. Extend or inherit. Okay? You cannot extend a class from more than one class. For example, yesterday when we were talking about the animal class hierarchy, we were talking about the animal class being the base class, and then we have two-legged animals, four-legged animals, and we saw that two-legged animals walk with two legs, four-legged animals walk with four legs, but a monkey can extend both from the two-legged and the four-legged because sometimes it walks on two legs, sometimes it walks on four legs. So do you classify a monkey as a two-legged animal or a four-legged animal? So you cannot inherit from both. You cannot say a monkey is both a two-legged animal and a four-legged animal. So what you can do is, you can create, instead of using an abstract class, you can create an interface called two-leg walking animals and four-legged walking animals, and have the monkey interface both those interfaces. So in one interface you have a method called walk using two legs, and another method you have an interface called walk using four legs. So the monkey can provide implementations for both of them. It can walk using two legs or it can walk using four legs. So what you can do is, you create, instead of an abstract class, you create multiple interfaces and have a class implement both those interfaces. So you provide implementations for both of those methods in that class. So whenever a class implements a method, whenever a concrete class implements an interface, it has to provide the implementations for all those methods that the interface provides. Yes. So every class can have it, every concrete class can have a different implementation for an interface. Okay. So I have an yes. Bodies. So yeah, it's a very good question. So his question is, what is the main advantage of an interface when every concrete class has a different implementation? So that's where we come to the concept of runtime polymorphism, and you'll see the benefits of that. Okay, with an example I'll show you that. Okay. So first let's take an example. Okay, I have an example, so let's look at that example. So let me save this file here. MI is multiple inheritance. Java does not, okay, listen first before you write. Java does not have multiple inheritance. Okay, can you all pay attention here? In the brackets here, I said workaround for MI. MI is not Mission Impossible. It is multiple inheritance here. Okay. So I said interfaces is a workaround for multiple inheritance. Java does not have multiple inheritance. So to support multiple inheritance, you use interfaces, but you still don't inherit from more than one class. You implement more than one interface. So that kind of gives you the benefits of multiple inheritance. I'll show you an example, okay? When you come to the example, you'll understand it better. So I have one example where you do something with abstract classes. and then I want you to convert that whole hierarchy using interfaces. So your assignment will be to convert it to interfaces. So the program that I give you will be with abstract classes. Okay. I want you to convert all the abstract classes to interfaces. To interfaces. Convert the abstract classes to interfaces. Okay. Only all you have to do is replace the word abstract class, keyword abstract class with the keyword interface. Okay. So let's look at this. Okay. This is the shape hierarchy. We already looked at the shape hierarchy, right? So did I make a diagram of the shape hierarchy? Right. So let's go there. First, let's look at the class hierarchy. Okay. I don't like this Corel Painter. It's kind of slow.